Hello friend, I'm reaching almost to the end of the KNN classification, and you can see over here a few more data frame got added. Let me tell you what these is all about, and let me show you the code as well. So here I have imported the K neighbors classifier from the package sklearn neighbors, and also I have gone for the I want to figure out how much score or how much accurate is my model. So for that reason I have imported the package sklearn matrix, and on the top of that you have to go for train underscore test underscore split, because you have to split your data set. Okay, so these three are the important packages you need to incorporate. So let me bring you down over here. As you can see, in my last video I said that I have to split my independent data frame and as well as the dependent data frame into two separate, so that I can go for train test split, which I have done right over here. See, if you look over here, I have given a call to train underscore test underscore split function, and I'm passing over here the matrix, or to be more specific, pandas data frame that contains all the independent features. And this is the panda series that contain one dependent label, or the result, you can say so. And here I have gone for the test size of like 40% of the data set I will be using for testing purpose. And I just gave a call to random state, so that every time I run my code, I will be able to see the same data selected, same row selected. So once you fire this particular function, you will be getting 4 outcomes. And what are these 4 outcomes? I will be showing you graphically over here in the page, so that it is very crystal clear to you. Xtrain and Ytrain, Xtest and Ytest. Now what are these all about? Well, this is what you can understand right over here. Let me show you this. That means this is my actual independent features, and this is my dependent label, right? So what Xtrain and Xtest, what it has done is it has taken 40% of the row from this actual data set. Like it has taken, the Xtest has taken following data, like row number 14 it has taken. So over here, row number 14, this particular data it has selected, and for that row number 14, this is the dependent label, that what it has taken over here. Similarly, it has gone for the 0th index, this row it has taken that, and this is the label of this. In this way, it has taken certain number of rows, I mean 40% of the total data set. From the total data set, 40% it has taken for the testing purpose, and it has selected randomly. A random state 2 I have taken. So if you run this code, you will be getting exactly the following rows, okay, and that will be fixed. So that means over here, this is the data set that is considered Xtest, and this is the actual output of the following rows is what called Ytest. Okay, the same way I have got Xtrain and Ytrain, but due to lack of space I didn't show you that. The rest of the other leftover rows will be under the data frame called Xtrain, and the subsequent result would be under the Ytrain, and that's how this particular train test split function result. And this is very important in almost all the machine learning algorithm. You will come across this particular function, and that's the reason I wanted to show you graphically, so that it's very crystal clear to you. And here I have shown the data also. I have converted this into, okay, one more thing that is very interesting. That means once you have gone for this trend test, since I'm showing the result in the browser, so I can go for a minute accurate understanding that the outcome what we are getting is a pandas representation or is a numpy array. Everything I'm getting an hands-on proof. And for that reason, this Ytest, okay, this Ytest which you can see over here, I have to convert it into pandas data frame. That means it was given as numpy single dimension array. So after converting that Ytest, I can split it right over here. As you can see, Ytest has splitted. Similarly, Xtest by default, Xtest is a double dimension array. So for that reason, it is given as pandas data frame. So I don't need to convert it to data frame once again, because it is a by default data frame. So that's the reason you can see right over here. Okay, so that's how the following data is coming. Now once I have printed this, what about this one? I will get to this particular column. This is where the beauty lies actually. So the trend tests training and training and testing data set has been done. So now you go for the actual beauty, that is the KNN. You give a call to KNN, and what this KNN all about? This is the KNN neighbors classifier, and that takes couple of arguments. It takes a number of neighbors. I've given 3 over here. You must be wondering what is the relevant of this parameter. Don't worry, I will tell you. And the distance which I will be using, the distance type I will be using is the Euclidean distance. As you know that the formula is under root of x2 minus x1 whole whole square plus y2 minus y1 whole square. That's what the Euclidean distance is all about, which is based actually on the Pythagoras theorem. That what is actually been used, and that's how the classifier object gets created. So you must be wondering, what is the meaning of this line? What is this 3 actually means? For a better understanding, I have gone for a graphical representation. Let me show you that for your understanding. So imagine this is a graph, and over here this is one set of data classified. This is another set of data classified. So there are two basically data set are there. Now you introduce a new data point, and the question is, this particular data point will fall under which particular category, the category green or the category orange. That's what we have to regulate, and for that reason we are using the distance formula, that is the Euclidean distance under the KNN classifier. And when you're going for KNN classifier, you have to mention the number of neighbors. I've gone for 3. So what does this 3 means? It will pick up 3 data point, and then we will try to find out that the new data point, how close this new data point in context to the following data point which were mentioned. So K3 means I've taken 3 data point, and we will find out the nearest, how many of the data point that is nearest to this particular new point. And as you can see over here, this is pretty nearest to the new. This is also quite nearest. So since the number of weightage for the data point is the 2 data point, you can say, so who are close to this new data point, so hence this particular new node would belong to this orange group. Okay, that's how it has been selected. So K would represent how many data point you will put over, on basis of which the new data point will be compared. You can go for K3, K4, K5 according to your choice, depending upon the total number of data that your data set contains. So over here I have gone for 3. So that means, as you can see right over here, 3 data point, it will be compared, and accordingly it will insert or it will just post the new data point in that particular group. So that's how this K stands for. And once you have created this particular object, now you have to go for the actual training, and that brings us to the fit function. So the classifier dot fit, what you will be inserting? You will be inserting the x train. That means the x train, that means the leftover rows. This is the white x test. So the leftover rows are actually in the category of x train. That's what you are going to put over here, and associated to those rows, what is the dependent label? That what you are passing over here. So that means this is what called supervised algorithm. So in case of supervised algorithm, you already have the data set with you, which you are actually feeding. So over here, the actual data set, the output of that particular data set also you are providing, and that's how your machine is actually get trained, and that's where the classifier is getting trained. Okay, so this would actually train the classifier that based on this independent features, this is the resultant output we are getting. So the classifier is getting the knowledge, so that when it will be exposed to some new data set, which we will be doing over here very soon, then it will tell me what is the predicted outcome, or what is the dependent result that we are going to come across, and that's what now we are going to do it. So once the training has been done, now we go for the prediction. So classifier dot predict. So previously when we train, we use the classifier dot fit, and now when we are going for training, it is classifier dot predict, and here I'm passing the x test. That means this particular data frame is what I'm passing, and we already know what is the outcome of this data set. The corresponding the output is right over here. We know that. We know it very well. So when we are doing the evaluation, at that time we will just feed the independent data frame, will not feed the dependent result. We'll go for the comparison. So once this testing has been done, once the predict has been done, it will generate the corresponding output, and that is the y predict. This is the y predict that it is getting generated. So once the classifier has got, after the training has been done, we are exposing the classifier with a fresh new data set. So it will generate the output, and this output is what I'm printing, as you can see right over here, and this is the output which you are printing. We know the corresponding independent feature has this output. We know that. Now we'll go and compare that how many output is actually correct, how much is the prediction rate. We will compare that, and look over here, I have gone for the accuracy. I have gone for the accuracy. While you are going for accuracy, you will send the actual data set, the output which we have got in the data set, we'll send that, and the predicted result also will send that, and then we will pass these two series, you can say. This is also a single dimension numpy array, this is also single dimension numpy array. We'll pass that and it will generate the accuracy, and that accuracy is going to be printed over here. So let me show you the accuracy. So for that reason, I will open my terminal over here and let me refresh the code. Let me refresh the page once, and as I do that, so my output is right over here, and as you can see, the accuracy level is 0.70. that means it is 70% accurate. Not that bad, because we have got a very limited number of data sets. We have just got 25 rows, out of which we were using 40% of the data for the evaluation purpose, for the testing purpose, and the prediction has been not bad, 70% accurate it has said. Now why it is saying 70%, let's that evaluate. And let's see the comparison right over here. So when my row is, if you look at the row number 14, this was the following data, and here is the actual row. If you go, say, I have kept all the data frame in front of you so that you can go for a comparison. Hardly you will find this kind of video. I have seen many videos in YouTube, but hardly this kind of presentation graphically in the form of browser Django based, I hardly have seen. So that's the initiative which I have taken. So as you can see over here, this row, if you see, this row has given us actual output was the person will not buy the book, but the predicted output is the person is going to buy the book. This is the prediction it has gone. Okay, fine. So that's not a correct prediction. Nonetheless, if the row, if you go for the index number 0, the prediction was the person will buy the book, and in my model has predicted the person will not buy the book. This is also wrong. And if you go for the row 17, let's find over here, the actual data was the person is going to buy the book. That's also over here, and the prediction was the person is not going to buy the book. So 3 rows are actually incorrect, and rest of the other row you can see are actually correct. So that means that's the reason why it has said 70% is accurate, because 3 rows are actually incorrect and 7 other rows are all correct. As you can see, they are all correct prediction it has come up with. So that's not a bad, isn't it, right? As far as the 25 rows are concerned, so more number of rows would have given more accurate result. Nonetheless, this accuracy is not that bad in fact. Okay, and now I have gone for one more thing which I have gone, that is, this was based on the entire data set. What if I give a user input? Okay, well, right now I don't have any HTML form over here. In fact, I have thought about even that also, that I will go for HTML form where the user will fit the data at the runtime and then we'll go for the prediction. Not that a bad idea. I have also thought about to do that, but until then what I have done is that I have created one dictionary over here. So I've considered this for features: age is 20, student as like whether the person is student or not student, income is 1, and saving is 1, and corresponding the 0 means over here, as you can see, the student, no, the student is not a, if the person is not a student, then it will be 0. So in that way the mapping has been done. And if I have created this dictionary and I'm passing, okay, before, since it's a dictionary, now I have to send the data in the predict function right over here, as you can see, in the form of a data frame. So I have to convert this dictionary into pandas data frame, and for that reason again I'm giving a call to pandas data frame. So typecasting is going on, I'm passing this dictionary, and since I'm inserting this dictionary into the data frame, and data frame means it's a multi-dimension array, so I have to tell that which index this particular data frame will be inserted. So these minute details you will be observing if you come across the data in the form of a browser base. If you are doing it in Colab or Jupyter Notebook or in Anaconda Navigator, these things will not come in picture. You can check out other videos, you will find these things are not taken in consideration. But since you are displaying the output in a Django, in a web page, so all these typecasting is very much essential, and that actually takes a lot of time, you know. So over here I have converted this dictionary into Python, into pandas data frame, and I have inserted the row, and this input now I'm passing it to my classifier, and again I'm going for a prediction. This is just one row prediction, and the resultant output I'm going to pass it over here, and this output I will check what is the output, and this output will also in the form of a pandas array. So for that reason, since I've just got only one row, so I'm specifically telling the index that whatever output will be there at the index number 0, that output would be. And as you can see over here, the output is just given 1. That means if following input is given, then my model is saying that the person can buy the book. So that's the reason 1 has been given over here. Okay, although I have taken the hard coded value, but still it can be understandable that how the flow is working on. if possible, if I can make out time, because I have to work on other algorithm as well, I might come across a HTML form where I can take the input from the user, pass it in the Django, and then I can go for the prediction. Nonetheless, this is also will work and make you understand that how dynamically user input can be taken, and from there how accuracy, how prediction can be done, and accuracy also has been shown over here. Okay, so that's how this particular application has been. We have continuously there this with this video number 5, in which I finally ended up by showing you how the KNN is actually going to work. I believe you understood the model and the concept, and the whole thing was a Django based. That's what the challenge was. Okay, so in my next video I'll be talking about the next supervised algorithm. So keep watching. Have a nice time. Bye bye.